Concept 2, exploring the effects of changing dimensions. So we have gone over how to calculate the volume of a triangular prism like this, a triangular pyramid, or a cylinder. All right, and now we're going to look at what happens when we change the size. Okay, maybe we increase the height, maybe we increase the width or the length, maybe we increase all three. Okay, so we're going to look at how that changes. So I've got my basic formula here for finding the volume, and I'm going to add, right, oops, starting that wrong. Okay, add that my base for this is going to be length times width, right? So my overall formula is going to be length times width times height, right? For finding the volume of this rectangular pyramid, this box. Okay, so now I'm going to plug in my values to see what my original is. So the volume should equal 4 times 4 times 6, which 4 times 4 is 16, times 6 should be 96, but let's check. 4 times 4 times 6, 96. All right, we got it. So the volume of my original is 96. Okay. Now, what happens if I go ahead and double this side? Okay. So instead of 4, this is 2 times 4. This will be 8. All right. I'm going to take my volume is 2 times 4 times 4 times 6. So this is me doubling my length. Right? Well, let's go back to here, and I'm going to go 2 times 4 times 4 times 6. 192. 192. Well, that looks like that's twice as much to me. Right? Twice as much as my original. And I can figure that out, make sure, by dividing by 2. Yeah. So when I multiply one of my sides by 2, I make it twice as long. My volume increases by 2. Well, that seems pretty standard. That seems to make sense, right? If I multiply all of these numbers by 2, my result is going to be twice as big. Okay, and that'll be true no matter which side I double. Okay, or triple. If I was tripling the length, my volume should be triple my original. Okay, what happens when I double two sides? What happens when I double both sides of the space? Okay, I'm going to have volume equals 2 times 4 times, 2 times 4 times 2 times 4 times 6. Okay, well, what's going to happen? Is it going to be 3 times as much? 4 times as much? Let's see. 2 times 4 times 2 times 4 times 6. 384. 384. And if we divide that by 2, it's back to 192. If we divide it by 2, back to 96. So it is 4 times as much, right? Which makes sense because 2 times 2 is 4, and I'm multiplying all these together. Okay? So if 2 of my sides that I double makes my volume 4 times as big, what if I double all 3 sides? How much bigger should it be? Okay? Well, if I double all 3 sides, it should be my original, my 4 times 4 times 6, times 2 times 2 times 2, right? Because that's basically what I would be doing, is I'm just adding these 2's in there. So 2 times 2 times 2 is 8. So my new volume, if I double all of my sides, should be 768, right? It should be 8 times as big as my original. Well, let's make sure that that's the case. So 768. Okay, and so this is 2 times 4 times 2 times 4 times 2 times 6. Let's see if that's what my new volume is. 2 times 4 times 2 times 4 times 2 times 6. 768. All right. Great. So that looks like we have that figured out. Okay. In a rectangular prism, in a triangular prism, whatever we multiply by to increase our side length, right? So in this case, we multiplied it by 2, and then 2 again, and then 2 again, is what we're going to multiply by our volume. All right? So that's true for a rectangular prism and a triangular prism. Let's look at a cylinder, because a cylinder is a little bit different, right? It doesn't quite have the same type of formula as the other two. It starts out with the same formula, right? Big base times big height, okay? But my formula for my big base is going to be pi r squared times the height, right? So this is a little different. This is r squared, right? We don't have that exponent in our other formulas. Okay. So let's look at how this changes. If I double my height, okay. Oh, I'm jumping ahead of myself. Let's calculate my original first. So that's going to be pi. I'm going to keep, and then the radius is 4 squared times a height of 10. 4 times 4 is 16. Times 10 is 160. So the volume of my original should be 160 pi. And I'm going to leave it in terms of pi because that way I don't have to mess with all the decimals. And this is a really accurate calculation for the volume of this. If I multiplied it by 3.14 instead of pi, it wouldn't be perfectly accurate anymore. It would be off. Okay? Okay, so I've got my original. Now I'm multiplying my height times 2. So that's going to be my volume is equal to pi times 4 squared times 2 times 10. All right, so I already know 4 times 4 is 16, times 10 is 160, times 2 should be 320 pi. Okay? Right? I just multiplied it by 2. So it did the same thing as my rectangular prism and my triangular prism. Okay? Now let's look at that radius. That's the one that's kind of throwing me off. So if I double my radius, okay, I say it's 2 times 4 or 8. Okay? If I have my pi times 8 squared, and let's go back to our original, times 10. Okay, well now what's 8 times 8? What's 8 squared? 8 squared is 64 pi times 10 would be 640 pi. Well, that's a lot different. That's double, right? That's twice as much as when I doubled my height, and that's 4 times as much as when I doubled or when I didn't double anything. That's 4 times as much as my original. Why would doubling my radius make my volume increase by 4 times on a cylinder? Think about it. Why would it do that? Well, if I come back up here, I remember that when I doubled these two, right, when I doubled my base, it increased my volume by 4, right? It went from 96 to 384. So that seems to indicate that maybe we're doing the same thing here. And that makes sense when we look at our formula, right? We are squaring our radius. Our radius is kind of saying, okay, it's squaring it is kind of saying, well, it's this dimension times this dimension, right? And that makes sense because that's what gives us our area. Okay, so when I square my radius, when I increase the size of my radius, it's actually increasing both the length and the width of my base. So that's why my volume is increasing by 4. All right. So, for all of your dimensions other than the radius, whatever you multiply them by is what you can multiply your original volume by to get your new volume. Okay? But with the radius, you need to multiply it not only by what you're increasing, right? I'm multiplying it by 2, but I'm multiplying it by 2 twice, kind of, because I'm squaring it, right? So if I'm doubling it and then squaring it, that's going to be 4. If I had tripled it for my radius, tripled my radius, that would be squaring it. That would make my volume increase by 9 times. Okay? So this is how you can figure out what an increase in your radius will do to your volume. If it doubles it, it's going to make your volume 4 times as big. If it triples your radius, it makes it 9 times as big. All right?